Hello everyone. I
All are
hope
doing
you.
great. So I am Sahil Ahmed from Civil Second Year, and today I am going to give a lecture on the topic cement, and which has been assigned by Mr. Mohsin Jamal sir. So moving on to the first slide. Here are the points which we are about to learn in this module. So first of all, introduction, then manufacturing of cement, then constituents of cement and their role, and then clinker composition, the hydration of cement, tests on cement, types of cement, uses of cement. Now here are some historical facts about cement. Now the first point is that a man named Joseph Aspirin, who lived in the UK, invented the Portland cement, and it was in the year 1824. Now here is a short story of how he formed the mixture, which is now known as cement. Now first of all, he used a mixture of limestone, clay, and water. Then he heat them at a high temperature, which then was formed cement. Now in this picture, you can see here is the, you can call a mountain or mountain of limestone, and then in this picture we can see that is clay. Now when limestone, clay, and water were mixed, a mixture named cement was formed, and he was granted a patent of this on 21st October 1824. In this picture you can see that Portland stone is being excavated from the mines, and UK is a major producer of Portland stone. Now before cement was used, Portland stone was used for construction purposes. In this picture you can see that Portland stone is used for construction, and in this picture also. So, and this is a very popular building also, which is known as St. Paul Cathedral Church. Now here are the classification of different materials found on inside an earth surface. Now the materials which are found on and inside the earth surface can be categorized in three types, that is calcareous, argillaceous, and siliceous. Now in calcareous, basically the major constituent is CaO, that is calcium oxide, and in argillaceous material the major compound is Al2O3, and in siliceous compound major compound is SiO2. Now here are some examples of calcareous materials, that is limestone, chalk, marine shells, cement rocks, and for argillaceous there are shale, clay, cement rock, chalk, blast furnace, slag, marl, etc. Now in case of siliceous, there is sandstone and silica. And the basic constituents of all the material on earth and inside earth's surface are, these are the basic constituent of all materials found, that is lime, silica, alumina, iron oxide, and magnesia, etc. These are the major compounds. So here is a flow diagram which shows the manufacturing of cement. First of all, raw material is collected and stored, that is such as Portland stone, clay, etc. And then they are mixed in correct proportions with and then they are pulverized, that is powdered form, in ball mill. And after that, calcination in kiln. Now here is the process which is shown, that is calcination in kiln, which is basically heating. Now in this process, balls of the mixture of cement forms, that is known as clinker, and this is formed due to the rotatory motion of the rotary kiln, and this motion is similar to the process of kneading. Now when the clinkers are formed, then they are cooled, and after that pulverized clinker and gypsum is added to them, and then they are stored and packed. Now calcination is a process in which the substance is heated in high temperature but below melting point, such as that the substance is in between the melting point and it is also heated. Therefore, it is between the solid and liquid states. It is in a mid state, that is a plastic state, and it enables the substance to fuse. In this process, CO2 is evolved, and in this process, a temperature is maintained between 1300 to 1500 degrees centigrade in a rotary kiln. And this is a picture of a ball or tube mill. Now here is a flow diagram which shows the manufacturing of cement. Is a picture which shows the manufacturing of cement. Now in this first process, the raw materials are excavated and they are then sent to the storage, and here they are mixed in correct proportions and they are then fed to bins, and after that it is delivered to the raw mill and they are mixed with water. You can see here electrostatic precipitator. From here the water is mixed in the mixture, and then it is delivered into the rotary kiln where it is heated with the help of different type of fuels. Now then the clinkers are cooled over here with the help of clinker cooler. You can see here the cooler dedusting, and here is the system which provides the fuel for the rotary kiln. And after that the clinker are stored and admixtures are added in the compound, and then it is delivered to the cement mill, after that to cement silos, and then packaging machine, and then to different type of stores and dealerships. Now then here is a flow chart which shows the manufacturing of cement via dry process. Now in this process there are two types, in which a calcareous material is used and in the another one in which the argillaceous material is used. Basically in calcareous material limestone is used, and in case of argillaceous material clay is used. Now first of all, in calcareous material it is crushed and fine grinding is done in ball mills and tube mills. After that it is stored in a basin and which is delivered through a channel for mixing. And in case of argillaceous material, the crushing is done and fine grinding in ball mills and tube mills is done and they are then delivered to storage bin, and then for the mixing of the for mixing in correct proportions. And preheating is done by exhaust gases at 800 degrees centigrade, and storage tanks are used for raw mix, and fuel is fed from lower end to rotatory kiln. Suppose this is a rotary kiln and these are the fuel, which is basically thermal energy obtained from coal, etc. And the rotary kilns revolves around an axis, and then clinkers are formed due to rotary motion, and then the clinkers are ground in ball mills where they are added by 2 to 3% of gypsum, and then they are sent to cement silos and then packaging plant. And manufacturing of cement via wet process. Now the basic difference between wet process and dry process is that in case of wet process water is used, and in dry process water is used in 0%. Now in case of calcareous material in wet process, it is sent to crusher, then storage bins, then wet grinding mills, ball mills to make slurry. In this case slurry is made, whereas in dry process only powder is made. Now for argillaceous material it is sent to wash mill, then storage bin. Then from ball mill, blending of slurry to correct composition, so it is mixed to correct composition. Now then it is stored, and then it is sent to rotary kiln from upper end, and fuel fed from lower end, and the fuel is basically coal, oil and natural gas. Now the slurry is converted into clinkers. Now clinkers are ground in ball mills in which 2 to 3% of gypsum is added, then cement silos, then packaging plant. Now here are the constituents of cement and their role. Now in cement, basically 7 constituents are there, that is lime, silica, alumina, iron oxide, magnesia, soda, potash and sulfur trioxide. And their functions are such as that as and here the average composition of them are mentioned. Now the function of lime is that it controls strength, soundness, and if lime decreases, strength and setting time also decreases. Therefore, the strength and setting time of cement is directly proportional to the constituent of lime. Now, lime controls strength and soundness. Now, soundness is basically the maintenance of the volume of the cement when it forms concrete, and it must be present in about 63%. Now, silica gives strength. Now, if it is present in excess, it increases slow setting time, and it must be present in about 20%. Now, alumina. Now, alumina is responsible for quick setting, and if it is present in excess, it lowers the strength, and it must be present in about 6%. Now, in case of iron oxide, it gives color and helps in fusion of different ingredients, and it must be present in about 3%. Now, in case of magnesia, it imparts color and hardness. If it is present in excess, causes cracks in mortar and concrete and leads to unsoundness, and it must be present in about 2%. Now, soda and potash. If soda and potash are present, then it causes residues, causes efflorescence and cracking, and they must be present about only 1%. And if it is present in excess, then it causes efflorescence and cracking. Now, sulfur trioxide, it makes cement unsound, and mostly they are present in about 1.5%. Unsound means basically that it controls the change in volume from the transition of cement to concrete. Here are the most commonly used additives, that is fly ash, which is used in 1%, and it is also used as an admixture these days to improve workability but does not affect the strength. Now here fly ash also plays a major role in eco-friendly and sustainable manufacturing of cement, because fly ash is a major disposed material from our thermal plants, which are mostly used all over our nation. And gypsum is also used in 2 to 3% in order to increase the setting time. Now, clinker composition. Now, when clinkers are formed, basically it produces bulk compound. There are 4 major bulk compounds present. Now, here is a temperature transition in the manufacturing of cement. Now, in rotary kiln, a temperature of about 1200 to 1300 is maintained, and after 15 minutes it is brought down to 500 degrees centigrade, and after 10 minutes it is exposed in ambient temperature. Now, the composition of the 4 bulk compounds are tricalcium silicate, dicalcium silicate, tricalcium aluminate and tetracalcium aluminoferrite. Now, here are the formula of these compounds. Here are the pet names of this compound, that is alite, belite, silite and phthalite. And the symbol are C3S, C2S, C3A and C4AF. Now, in here the symbol C stands for calcium oxide, S stands for SiO2, and A stands for Al2O3 and F stands for Fe2O3. And beside this, there is also alkalis are present in the bulk compounds. Here are the properties of the 4 bulk compounds, that is tricalcium silicate. and the average composition, that is 40%, must be present. Now it provides best cementing property and it's formed when cement is well burnt. It provides early strength and is responsible for 7 days strength. It enables clinker easy to grind and increase resistance to freezing and thawing. Generates high heat of hydration and increase solubility of cement in water. And the heat of hydration is 500 joule per gram. The next bulk compound, that is dicalcium silicate, must be present in about 32%. It hydrates and hardens slowly and takes long time to add to strength, and that is later strength, which adds to the ultimate strength of the cement. It enables clinker hard to grind and decrease resistance to freezing and thawing. So, in case of tricalcium silicate, it increases resistance to freezing and thawing, and in case of dicalcium silicate, it decreases resistance to freezing and thawing, and it adds to later strength and it adds to early strength. So here is a basic difference. Now here high heat of hydration is generated, and in case of dicalcium silicate, low heat of hydration is generated and decreases solubility of cement in water. It imparts chemical resistance, and its heat of hydration is 260 joule per gram. The third bulk compound, that is tricalcium aluminate, must be present in about 10 to 15%. It reacts immediately with water and is responsible for flash shed. It is the first compound to react with water. So, therefore, tricalcium aluminate is the first compound to react with water when the cement is mixed with water. It decreases setting time, hence increased shrinkage and cracking. It weakens resistance to sulfate attack. Volume change increase and hence cracking. Heat of hydration and lowers ultimate strength. So for tricalcium aluminate, setting time is decreased, in shrinkage and cracking is increased, and it weakens resistance to sulfur attack, and its heat of hydration is also very high, and it lowers ultimate strength at 65 joule per gram. Now the fourth bulk compound, that is tetracalcium aluminoferrite, must be present in about 9% in the cement. Now it is responsible for flash set, but generates less heat. This has the poorest cementing value. If it decreases strength, and it also has a moderate heat of hydration, that is 420 joule per gram. And here are some points on hydration of cement. Now chemical reaction of cement with water happens to produce CSH gel, that is also known as etrinate gel. These reactions are highly exothermic. Only C3S and C2S react with water to produce C3S2H3, that is calcium silicate hydrate, which is mainly responsible for strength and densifies as cement sets. Now along with CSH gel, CaOH2, that is calcium hydroxide, is also formed as byproduct. Now CaOH2, that is calcium hydroxide, is an undesirable product because it causes sulfate attack. Now C2S gives better cementing properties than C3S as it produces more gel and less CaOH2 in long term. Now hydration of cement depends on ingredients. Fineness increases, then surface area increase, then rate of increase. And in case of temperature increase, rate of reaction increase. Here is the order of heat of hydration of different bulk compounds. Arrangement of different bulk compounds. Now in case of order of heat of hydration, now C3A has the greatest value, that is 865. Then comes C3S, which is having a value of 500. Then C4AF 420, and then C2S 260. And in case of order of rate of hydration, that is speed of reaction, C4AF has the greatest rate of hydration, then C3A, then C3S, then C2S. In order of strength, C3S is the greatest, and then C2S, and C2S is very greater than C3A, and C3A is greater than C4AF. In case of order of setting time, C3A has the quickest setting time, then C4AF, and then C3S, and then C2S. Therefore, C2S is responsible for the later strength, and C3A is responsible for the early strength. Now, sulfate attack. In case of sulfate attack, solid sulfate does not affect severely. Water sulfates proves fatal as it reacts with gel and the volume of cement paste increases in concrete or mortar. Now here is the reaction. Now C3A in the process of hydration forms calcium aluminium hydrate, and then sulfates attack, and after that calcium aluminates are formed, which results in higher volume of the concrete. Now here are the sources of sulfates. Some sources of sulfates, it occurs in soil, groundwater, seawater present in bricks, bacterial action, sewers. Now here is a picture which shows falling due to sulfate attack. Now here you can see there is an increase in volume due to sulfate attack. Now these end products causes increase in volume by 127%, which causes the concrete to expansion, extensive cracking, loss of bond between cement paste and aggregate. Gypsum has to be controlled up to 3%. Here are some tests on cement. Tests are conducted to determine properties of cement and regulate various stages in manufacturing for quality. In case of field tests, color, presence of lumps, strength, density must be tested. And in case of lab testing, there are two divisions, that is physical test and chemical test. In case of physical test, fineness test, consistency test, setting time test, soundness test, strength, heat of hydration, specific gravity. And in case of chemical tests, loss on ignition, chemical composition must be done. So field testing, cement color must be greenish gray. If rubbed between two fingers, it should feel smooth, not rough. If hand is inserted in bag on cement, it should feel cool and not warm. If thrown in a bucket of water, it should sink and not float on water. A thin paste of cement should feel sticky between fingers. It should be free from lumps. If present, indicates absorption of moisture from atmosphere. Now, if a briquettes, that is this picture you can see, which is of size 75 into 25 into 12 millimeter, made with 1:1 cement sand ratio, that is 1 part of cement and 6 part of sand. Proportion should not break easily, kept under water for 3 days. So it must be kept under water for 3 days and should not break. Now physical test. Number 1 physical test is fineness test. And in case of fineness test, there are 3 processes, that is sieve test, air permeability apparatus, and Wagner's turbidity meter. Now in case of a sieve test, 100 gram of cement sample is taken, and sieve of 90 micrometer is taken, and after 15 minutes the residue is present. And for OPC cement, 10% residue by weight is permissible, and for RHC cement, 5% residue by weight is permissible. So air permeability apparatus, nuts and blends apparatus, head loss directly proportional to SSA. Now cement SSA is basically specific surface area. Now for OPC in 225, that is 2250 centimeter square per gram is permissible. For RHC 325, that is 3250 centimeter square per gram is permissible. Now in case of Wagner turbidimeter, a tank filled kerosene and cement particles are allowed to fall. Turbidity is measured, which gives idea about SSA. In physical test, number 2 is consistency test. Now this test is used to find quality of mixing water. Normal consistency P is that percentage of water required. Viscosity will be such that Vicard's plunger penetrates up to a 0.5 to 7 meter from bottom of the mold. It is useful in performing other tests. Here is the Vicard apparatus, and here is the Vicard mold. Here is the scale. This is the plunger, and here is a glass plate. Number 3 is setting time test for physical test. Now a sample is taken and a square needle of dimension 1 into 1 millimeter is released, and it penetrates only 5 to 7 meter from bottom of the mold. Now in OPC not less than 30 minutes. In LHC is equals to 1 hour. In lime pozzolana cement 2 hours. Initial setting time must be, and in case and in final setting time, the time at which needle makes an impression but the annular collar fails to do so. Now FST not more than 10 hours, that is final setting time must not be more than 10 hours. Now in physical test, attachment and test, 10 meter diameter plunger is used for consistency test, 1 millimeter square needle is used for initial setting time, and the 5 millimeter diameter annual collar is used for final setting time. Here are some pictures of the different apparatus used. So here is the plunger used for consistency test. Here is the apparatus for initial setting time test, and this is the apparatus for consistency test. This is the front view of initial setting time test. The 4 is soundness test. This change of volume of cement after setting. It is determined by two processes. One is Lash-Atelier's apparatus, and another one is autoclave test. So in case of Lash-Atelier's apparatus, it measures unsoundness due to pre-lime only. Unsoundness of cement should be limited to 10 mm. Here a sample of 100 gram cement and 0.78 P is taken. And here is a glass plate. The distance is 30 mm. And this is the brass mold, which has a thickness of 0.5 mm. And here is the indicators with pointed ends. And in case of autoclave test, it measures unsoundness due to both pre-lime and magnesia only. Expansion of cement should not be more than 0.8%. Now here, this is the split cylinder, a glass plate and a weight. Now strength test. Now strength test can be done via two processes, that is compressive and tensile strength. Now here a sample is taken of the given ratio. Now 3 cubes of size 70.6 mm are prepared and gradual compressive load is applied. Average strength of 3 cube is compressive strength. Now in case of tensile strength, 6 briquettes are prepared and gradual load is applied. Average strength of 6 briquettes is tensile strength. Now heat of hydration is measured by calorimeter and specific gravity is measured by Lash-Atelier's flax. Now chemical test. Now loss on ignition. 1 gram sample is heated in muffle furnace and loss in weight is observed, which should not be more than 4% in general. Now chemical composition. Now ratio of alumina / iron oxide should not be more than 0.66. Weight of magnesia should not be more than 6%. Now lime saturation factor should be between 0.66 to 1.02. Now here are the types of cement. Now first of all, ordinary Portland cement. Now ordinary Portland cement are of 3 grades, that is 33, 43 and 53. Now 3 days strength is equal to 50% of 28 days strength. Now 7 days strength is equal to 67% of 28 days strength. The fineness is of 250 centimeter square per gram, and initial setting time must be equals to greater than 30 minutes, and final setting time must be equals to less than 10 hours, that is 600 minutes. Now for rapid hardening cement, C3S is increased, C2S is decreased, plus finer grinding. Now the fineness must be 3250 centimeters square per gram. Now initial setting time must be 30 minutes and final setting time is equals to 10 hours. Now uses road repairs in cold countries. For fast removal of shutter, 1 day's strength is equal to 16 Newton per millimeter square. Now extra rapid hardening cement, that is RHC plus 2% CaCl2, uses road repairs in cold countries for fast removal of shutter. Mixing, transporting, placing of concrete should be within 10 minutes. Accelerator, calcium. Now here the accelerator used is calcium chloride. Now high alumina cement. The contents here are bauxite, limestone, iron oxide, and due to this fineness is increased and high temperature is given. It is similar to RHC but Ca3A is absent. Uses road repairs in cold countries for fast removal of shutter. Refractory cement, that is heat resistant, and it also has a high chemical resistance. The type sulfate resisting cement, it is similar to OPC but C3A is decreased, plus finer grinding. Uses lining of sewers, canals in coastal areas in seawaters. Now Portland slag cement. Portland cement clinker plus granulated blast furnace slag plus gypsum. Now high chemical resistance, that is sulfate resistance, low hydration of heat. Uses marine works. Now types low heat cement, low contents of C3A and C3S and more contents of C2S. Now initial setting time is 1 hour and final setting time is 10 hours. Slow rate of hardening, slow strength development, prevents shrinkage and cracking decreases. Uses mass concreting works, high temperature places. Portland Pozzolana cement. Portland cement plus pozzolanic materials plus finer grinding. Pozzolana siliceous material plus calcium hydroxide is equal to pozzolana lime compound, it is cementitious. A low rate of strength development, decrease in early strength, low heat of hydration, uses mass concreting works, marine works. Now, water repellent cement, that is hydrophobic cement. OPC clinker plus 0.1 oleic acid or stearic acid, uses in basements, watertight structures. White and colored cement, from pure white chalk plus clay free from iron oxide is equal to white cement. Now colored cement is equal to white cement plus 5 to 10% colored pigment. Now quick setting cement. Now this cement is finer than OPC and gypsum is not used. Initial setting time 5 minutes and final setting time 30 minutes in running water or underwater. And thank you for your time, and that's it for today.